This is calculus, and we're going to look at areas such as differentiation, and under differentiation we're going to look at different types of differentiation such as the product rule, quotient rule. We're going to look at critical points or turning points, limit of a function, etc., etc. All right, okay, so let's begin. All right, so this is our first question. It's a limit question. Now there are different ways of approaching a limit question. We have direct substitution, we have cancellation, and we have rationalization. Rationalization is like finding the conjugate of an expression. Usually these questions involve square root sign. Alright, and direct substitution, we just replace x with the value there. But sometimes, you have to be very careful, alright, when you're doing direct substitution. Sometimes when you put the value of x directly into the expression, you get 0 instantly, or you get an illegal operation to work out. For example, you get 5 divided by 0, alright, and that's an illegal operation. Alright, so be careful when you're doing when you're trying to figure out which approach you're going to use to solve limit questions. All right, okay, so just looking at this question here, we realize that direct substitution is the best option. All right, and when we substitute this directly, we don't get any illegal operation like dividing by 0, and there's nothing here to cancel. All right, so we're gonna substitute, we're gonna replace x with -2 in this question here. So we're gonna write about the square root sign, so we're gonna have -2 square plus 5. All right, and we know that -2 square is 4, positive 4, and 4 plus 5 is equal to the square root of 9. So our answer is plus or minus, sorry, let me just undo that. Answer is plus or minus 3. All right, so moving on. Alright, so it says if a function f is defined by that expression, then the gradient at x equal to is. Alright, so let me just flashback your memory a little bit. Alright, so when you have a straight line, right, we can find the gradient of a straight line. All right, now when we have a curve, oops, that's not a curve, that's a curve, right? These are two curves. Now we can't find the gradient of a curve, we only can find the gradient at a point that's on the curve. Now in CSEC maths, normally they ask this question, what we do is that we identify the point on the curve and then we take our ruler and we draw a tangent at that point. And what we do is that we find a gradient of that line. Alright? However, since we're doing calculus, we can use that approach. We can use a calculus approach to answer this question. Alright? And the calculus approach is that we're going to differentiate this function. Alright? But it's very important that you guys physically see what's happening. Because sometimes when you just see a question, you might be asking yourself, how is this applicable? Why are we doing this? And once you can't see what you're doing mentally, it doesn't make sense sometimes. All right. So what we have here is that this function is actually a curve. If you were to represent this on a graph, you probably get a curve, a cubic function actually. All right. Now cubic functions are usually looks like that, or something like that. That's a cubic function. All right, and we want to know. So let's, for example, we have our cubic function here, right? And we want to know what the gradient is at the point called x equals 2. All right, and it's like you have a graph. You'd have a graph. That's our x-axis. That is our y-axis. That's origin, and this will be x equal 2. All right. And we're not gonna draw a tangent and find rise over run. What we're gonna do is that we're gonna use calculus to do that, all of that. All right, so we're gonna differentiate f of x. All right. So we're gonna use f prime. And that's going to give us 3x squared subtract 6x. Alright, and we differentiate 5x. So get 5. Alright, but however, when we differentiate -7, we get 0. Alright. So to find the gradient of that function when x equals 2 is that we differentiate it, and when we differentiate it, this is what we're going to do now. We're going to replace x with 2 in that expression, and that will give us the answer. So we end up with 2 squared subtract 6 times 2 plus 5. Now 2 squared is 4, and 3 4s is what? 12. And so I'm going down here. That's 12. 6 2s is also what? 12. And we have what? Plus 5. And you know that this will give us 0, right? So the answer is just 5. So the gradient of that function when x equals 2 is equal to 5. Alright, as you can see, that gradient is a positive gradient, so it will be like falling to the right. Alright, so let's move on to the next question. So this question is very similar to the previous one, but they're not talking about gradient. Alright, so they're just asking to find r prime. Now on r prime, when we do the calculus, would have mean that it will be the differential of what r is. So what we're going to do is that we're going to differentiate r. So r becomes r prime, or otherwise dy dx. So this will give us 30x plus 6. And we want to know what this value is when x is equal to 6. So we're going to replace x with 6. Sorry, not 6. It's 2. Just testing your skills, you know. Just testing your skills. Alright. So there's actually 2. I actually didn't realize it was 2, but So when we get our answer now, so 30 times 2 is what? Is 60. 60 plus 6. 60 plus 6 will give us 66. So R prime is equal to 66. Now they didn't tell us what they want to find, but it would look like a gradient question, but we wouldn't know. Alright, so for this question, all we need to do is just to differentiate, and we know to differentiate it because of this R prime. So R prime means that we're going to differentiate. When we differentiate the expression, we replace x with 2. Alright, so we're moving on smoothly. Right. So I don't want you guys to be this gentleman here. When them see maths, it's just like, you start act up in them head. Alright. So please don't focus on this diagram here. So let me stop it, buddy. Let me stop. Oops. Alright. Okay. So, alright. So we're given 2 functions and we're asked to find the limit of that function. Alright? As x approaches 3. As you can see, f(g(x) is a composite function. So we need to find f of g of x. Alright? So f of g of x, and this is how I would have taught it. And remember, you have other approaches that you could make. So what we do is that we start off with f function, so we just write out the f function. Alright, so when you write out f function now, what we do is that wherever x is in this expression, we replace x with a g function. So rather than having 2x, we're not going to have x, so we're going to have 2gx. Alright, so it becomes 2g of x. But what is g of x? It's x minus 3 plus 1. Alright, where the plus 1 come from? The plus 1 come from the original thing. The first letter, the first thing that come here is f, don't you? And f of x is 2x plus 1. So this plus 1 came from the original question. Alright, and we're going to use distributive law here with that bracket. So 2 times x is 2x. 2 times 3, negative 3 is negative 6. And that's plus 1. Notice I didn't multiply 2 times this one here. Be very careful. And minus 6 plus 1 is actually minus 5. Alright? So all of this here, right here, so f of g of x is actually 2x minus 5. So what we're going to do now is that we're going to find the limit, alright, or find the value of x, of that expression, as x approaches 3. Alright? And what we're going to do is that we're going to, based on my observation here, we're going to have to use, well, nothing can be cancelled. There's no square to rationalize. There's nothing to rationalize. Alright? So we're going to use direct substitution. Alright? So limit as x tends to 3. So meaning we're going to replace x with what? 3. So, alright, sorry Mr. Gentleman, but I have to go there. 2, 3, subtract 5. The 2 3s is what? 6. 6 subtract 5. The answer is just 1. Alright, so the value, as x approaches 3, this expression here, f of g of x, is actually equal to 1. Alright, so we're moving on smoothly. Alright, so alright, so this is another limit question. If you notice that you wouldn't want to use direct substitution here. Alright, if you were to replace x with 1, look at the denominator, look at the first expression here. This would have been 1 subtract 1, which is 0, and 0, and then this is going to be another 1, so it'd be 0 times 1 plus 4 is 5. So and 0 times 5 is 0. So we have a denominator, which is that's equal to 0. And you know you cannot divide by 0. Alright? So direct substitution won't work for this one. So what we're going to do, if you look at the numerator, this is a difference of 2 squares. So we have x squared subtract 1. And when we expand x squared minus 1, we get x minus 1 times x plus 1. Alright, so our numerator for this expression becomes x minus 1 times x plus 1. And what we're going to do is that we're going to write back the denominator, x minus 1 times x plus 4. And what happens is that the x minus 1 at the top and x minus 1 at the bottom will cancel, leaving this expression here. Alright, now notice that these two cannot cancel. So what we're going to do is that we're going to use direct substitution. Alright, so it's x approaches 1, so we're going to replace x equal 1 in this expression. Alright, so coming down here, so we have lim x approaches 1, and we have our expression here, x plus 1 over x plus 4, and so that's 1 plus 1, that's 2, and 1 plus 4 is what? 5. So the answer there is 2 over 5. Alright, so let's write back that 2 a little bit properly. Alright, so moving on to the next question. Question says, the critical value of the function is, alright, so let me try to explain something here. So let us say we have a curve, right, or a function like this. All right, now at these points, this would have been the maximum point and this would have been the minimum point. Now these points are called turning points, stationary points, or critical points. All right. Now the x value by itself of this point here, of these 2 points, it's called a critical value. Alright? Now, at the critical value, turning point or stationary point, dy dx is equal to 0, or f prime is equal to 0. Alright? In other words, the gradient of the function at the critical point is equal to 0. Alright, so to find the critical value is that we're going to differentiate this function and put it equal to 0 and solve for x. Alright, so f prime of x is equal to 2x minus 3. Alright, and the key point here is that at the critical point, f prime x is equal to 0. So what we're going to do is that we're going to put this expression here equal to 0 and solve for x. Alright, so clearly when we bring over negative 3, it becomes positive 3, and we'll just divide everything by 2. So the critical value there is x equals 3 over 2 or 1.5 or 1.5. Alright, so moving on to the next question. Alright, so you have to look at this question very carefully now. So we're asked to differentiate this function here. Alright, now when we differentiate ln x, and ln x represents natural logarithms, when we differentiate ln x, we get 1 over x. Alright, okay, now but look at this expression, it's not ln x now. Look carefully. What's beside it? There's an x beside it. Not true. So in other words, we're going to have to use what we call the product rule. Alright. Product rule. So what's a product rule? Alright, so this is how I have taught my students. Alright, and this is how I learned in high school. The product rule goes like this: first times the differential of the second. Alright, so I know in textbooks it doesn't actually go like that. Alright, but this is how I remember: first times the differential of the second plus the second times the differential or DC of the first. Alright, so let me just erase the top piece here. So remember that when you differentiate ln x, we get 1 over x, and we also established that we're going to have to use the product rule. Alright, alright, so it says first. Now first means they just write back the first term, so we'll write back the x. So first times the differential of the second means that you're going to differentiate the second term and differentiate ln x. When we differentiate ln x, what do we get? Yes, ladies and gentlemen, we get 1 over x. Then now we have plus now the second. What does that mean? It means it's going to write back the second term and times it by the differential of the first. Now if you differentiate x, what do you get? 1. Alright, and that's our answer. And we can simplify this a bit further. As you can see, x times 1 over x, what's going to happen? The x will cancel out, not true? And all of this is actually 1. And 1 times ln x is just ln x. So this is our answer. 1 plus ln x. So I hope you guys are following. Alright, let's move on to our next question while this gentleman is getting a haircut. All right, so this question is very similar to the one we did earlier on. So this question is asking us to find the gradient of that function when x is equal to 1. All right. So what we're going to do is that we're going to differentiate this and replace x with 1. Now notice the difference. Let me go back. All right, now a while ago for this question here, right, it says find a critical value. Now the critical value is also called the stationary point or the turning point. Now at the turning point or stationary point or critical point, the gradient is equal to 0. In other words, dy dx is equal to 0. All right. So, and if you want to know what the x value is when dy dx is equal to 0, we equate this, put it equal to 0, and we solve for x. But let's fast forward now. This question now, we have a function, but there's no critical point. So this is just a point on the curve. All right. So it didn't mention about turning point or critical point. So this is just a regular curve, and the point is just at x equal 1. All right. So what we're going to do is that we're going to differentiate this function here. All right. So this is going to be g prime x. So g prime x, this is going to give us 6 x squared subtract 4. All right, and then we're going to replace x with 1. So it's 6 times 1 squared subtract 4. All right, now 1 square is 1. So we work out this first. 1 square is 1, and 6 times 1 is 6. So we end up with 6 subtract 4. Answer is 2. So the gradient of this function when x equal to 1. So let me just try to give you a little picture of what's happening. So if you're to draw this g function, you get a curve like this. So imagine at this point here, that's where x is equal to 1. All right. So we want to know what the gradient is. Now in CXC, we would have just identified that point, draw a tangent, draw a tangent, draw a tangent and find the gradient of that straight line. All right, and when you find the gradient of that straight line, it turns out to be 2. So that's what we did a while ago. All right, so moving on smoothly to our next question. All right, so we have another limit question. So x squared minus 9 can be expanded, right? X squared minus 9, we can expand that to be x minus 3 times x plus 3. All right. But when you get that, and you divide it by 5, nothing will cancel. So that is not going to help us. All right. So we're going to use direct substitution. All right. So what I'm going to do, I'm going to replace x with -3. So we have negative 3 square subtract 9 all over 5. Alright, now what is negative 3 square? 9. So it's 9 subtract 9 over 5, which is 0 over 5, which is actually 0. Now, if we had 5 over 0, something would have been wrong. Alright? So 0 5 is 0. Alright. So alright, so this is a very simple question. So which of the following rules should be used to differentiate that function? So it's a multiple choice question, and the responses would have been given, but obviously it's a fraction, not true. So we would have used the quotient rule. Alright, so the answer is quotient rule. And the previous or two other questions we did before, we used the product. So moving on. Alright, so it says a firm's profit function is given by that. For what value of x is the marginal profit equal to 0? Alright? So we're going to differentiate this and put it equal to 0. Alright? So let's do that. I'm trying to find the icon there. So it would have become p prime x. So p prime x, well, when I differentiate this, well, let me just try to, well, 0.25 is actually a quarter. So we have a negative a quarter x squared. So what's going to happen is that we're going to multiply 2 times negative a quarter, which is negative 2 over 4, which is equal to negative a half. And you know, we subtract 1 from the power there. So when we differentiate all of this here, right here, so we get negative 0.5 x plus 3. Now it says what marginal profit when this is equal to what? 0. Alright? So we're going to solve for x. What I'm going to do, I'm going to bring over the negative 0.5x, becomes positive 0.5x. So we have 3 equals 0.5x. I'll just divide everything by what? 0.5. These two 0.5 will cancel out. So what do you know? X is equal to 12. 3 divided by 0.5 would have been equal to 6. Alright? So let me run this again. What we do, we differentiate that and put it equal to 0. And then we solve for x. So when x is equal to 6, the marginal profit is equal to 0. Alright, so in other words, whatever that variable represents, when that variable is equal to 6, the company or the firm wouldn't make any money. Alright. Alright, so looking at this question here, it says if dy dx is equal to x squared minus 4x minus 5, then the critical points are at x. Alright, now when is a critical point, you know? They're talking about x and y values. Alright? But luckily, just to make life a bit simpler, they didn't ask for the corresponding y value. It's just the x values. Alright? Now, to find the critical points, alright, what we would have done is that they would have given you a function. For example, y is equal to, say, 3x squared plus 6x. To find the critical points, we would have differentiated this and we would have gotten what? Dy dx. Alright? Let's differentiate this now. This would have been equal to what? 6x plus 6. Alright? And because it's a critical point, so at the critical point, dy dx is equal to 0. And then we solve for x. Alright? Now, there's a trick to this question. Well, you notice, they already give you what dy dx is, don't you? Yeah, so so in other words, you do not differentiate this expression. It was already differentiated. How do we know? By looking at the dy dx notation. Alright? So all we need to do now is just to equate this equal to 0 and solve for x. Alright, now as you can see, this is actually a quadratic equation. Alright? Alright, so to solve a quadratic equation, let me try to make some space. So what we do, we find out what is a in expression. A turns out to be 1. B is actually negative 4. And C is equal to negative 5. Alright? And what we do is that we multiply A times C, which is 1 times negative 5. 1 times negative 5 is what? Negative 5. Alright, so this is the number that we're focusing on. So you're going to ask yourself, listen carefully, you want two numbers when you multiply negative 5, and when you add the same two numbers, you get B, which is negative 4. Let me say it slowly. Alright, now when you multiply A times C and get negative 5, you're going to ask yourself, you want two numbers, when you multiply the two numbers, you get negative 5, and when we add the same two numbers, we get the B value, which is negative 4. So you're gonna ask yourself, boy, what two numbers will, when we multiply, gives you negative 5? Well, the first thing would pop up in your mind would have been 1 and 5. But you have to remember that this is a negative. It means one of the numbers have to be negative, but there's more to it. When you add those two numbers, you must get negative 4. So do I make the 1 negative, or do I make the 5 negative? No, it doesn't matter where you put the negative when you're checking for the product, because it doesn't really matter. So if you have negative 1 times 5, you get negative 5. If you have 1 times negative 5, you still get negative 5. But there's a problem when it's adding and subtracting. Now, because the middle term is negative 4, that means that you want the highest number there to be negative. So it turns out that negative 4, sorry, not negative 4, negative 5 and positive 1 are the numbers. Alright, now in the exam, don't come up with two numbers and don't check it. Don't come up with two numbers and praying that it is correct. Check it. Let's multiply these two numbers. When you multiply these two numbers, you actually get negative 5. Well, what I was saying earlier, if you put the negative at the 1, you still get -5. But at the adding part now, the tricky part. Let's add them now. -5 plus 1. So you owe Mr. Brown $5. You go shop with $1. You pay for $1, but you still owe Mr. Brown. Owe Mr. Brown $4. So what you notice, -5 and 1 actually works. Alright, now once you have identified those two numbers, this is what you do next. So let me write them down up here. So -5 and +1. Alright, so what we're going to do now, is it the middle term? We're going to erase it. We're going to remove it. So in the second line, you're going to have x squared. So you don't have this anymore, no? X squared, then now you're going to drop in these two numbers in any particular order. X squared subtract 5x. I always like to put the -1 first. Plus 1x. And notice I drop in the x's on the two numbers. Alright, so look, I roll back the first term and I roll back the last term and I drop in two numbers. Now because this term has 4 terms, we're going to factorize by grouping. So we have x squared minus 5x, so x would have been common. So what left back is just x. Subtract 5. And over here now, well, the number that is common would have been 1. And then we have x subtract 5. Alright, so I need some space down here. Alright. Okay, so now since because we have x minus 5 and x minus 5, it's common, not true? And because it's common, we're going to factorize it out. What left back now is this x and this plus 1. It's x plus 1. So I forgot to put the equal sign here. So everything is equal to what? 0. And then now we're going to split this bracket into 2 and we get x. Oops, x. So let me. X minus 5 is equal to 0. And x plus 1 is also equal to 0. I know when you solve this top piece here, you get x equals 5. And the bottom piece here, so is x equal -1. So what you notice, guys, these are the critical values. Alright? Or these are the critical points. At x equals 5 and at x equals -1. Now suppose you want the corresponding y values. You're gonna put these two x values separately in the original equation to find the corresponding y values. Alright? But because we don't have the original equation here, we'll have to leave it. Alright, so the answer for this is x equals 5 and x equals -1. And those are the critical points. Alright, so here we have another question. Now this question, they're telling us what the critical values are. Alright? They're telling us what the critical values are. But they want to know, they want us to find out what is the maximum value. Because if you have a curve, you know, and that's the critical point. These are the critical points. Alright? Without a graph, we wouldn't know that this point is a max and this point is a min. Alright? So let's proceed. Alright, so it says what is the maximum value? So what we're going to do is that we're going to differentiate this function here. Call it g prime. And when you differentiate it, you get what? 3x squared minus what? 27. Alright? No, you see, because, alright, suppose I didn't give you the critical values. What you would have done, is to put this equal to 0 and solve this. Alright, and when you solve this, you would have gotten x equals -3 and x equals 3. Alright, but you don't have to do that. They make the work simple. They just tell you that these are the values. Alright, but we don't know if when x is equal to -3, the point is a maximum or a minimum. Alright, and you might be asking me, how do we determine when the function is max or minimum? Alright, so this is what we do. Alright, now if you differentiate the function again one second time and you put in the critical values, the x values, and if that expression is less than 0, alright, or in other words, if it is negative, then function g of x would be a maximum. Alright, now if suppose it was positive, then gx would have been a minimum. What if it is equal to 0? Alright, so we call, when it's equal to 0, we call that point of inflection. Alright, okay, so I'm happy I got that out of the way. Alright, so we differentiate this the first time. So what we're going to do, we're going to differentiate it another time. Alright, when we differentiate it another time, we get 6x. Alright, now what we're going to do now is that we're going to replace x with these values, the critical values. So I'm going to put -3 there. If you put -3 there, you're going to get 6 times -3, which is -18. Alright, so when you put in the critical value x equals -3, the second derivative is negative. Alright, and if you can recall, being negative is actually less than 0, and once it's less than 0, it's called a maximum. Alright, so when I use x equals -3, the function is a maximum. Alright, so that's your answer. X is equal to -3. Alright, what if you put x equals 3 in this expression? You get 3 times 6, which is +18. So when x is equal to +3, the function would have a minimum value. Alright, so please skip back on the video, because sometimes this might be confusing. Alright, I hope not all the time it's confusing. Alright, so let me say this again. When x is equal to -3, alright, the maximum value is equal to -18. Now, why is that so? Let me run it again. Because when you differentiate it a second time around and input -3 in the expression, the entire expression, we get a numeric value to be -18. And previously I said that if the second derivative is less than 0 is negative, then the function is a maximum. If it's more than 0, it is positive, hence it's a minimum stationary point or critical point. If everything is equal to 0, we call that point of inflection. Alright, so I hope you guys get that. Alright, so let's continue. Alright, so this is a very simple one. When you differentiate in trigonometric functions, we have certain rules. Alright, so h prime, So what we're going to do is that we differentiate the 5x. If you differentiate 5x, what do we get? We get 5. Alright, so we put it right here. And then we differentiate sign, we get what? Cos. That's how you go. Yeah, man. And then you write back the 5x. Alright, and that's our answer. So it's 5 cos 5x. Alright. What happens when you differentiate cosine? If you differentiate cos, you get negative sign. Alright. And there's a little table that I did up some months ago or weeks ago. You can look back at it. Alright. Alright. So they ask us to differentiate this function here. It seems to be if we're going to have to use the product rule. Alright. And you remember, and you can recall that when you differentiate ln x, you get 1 over x. Alright, what happens when you differentiate e to the x? If you differentiate e to the x, so for example, d dx e to the x, when we differentiate that, we get back e to the x. Alright, so let me try to explain what's happening here, right? With another example. Suppose we get d dx e to the 3x squared. How do we differentiate that? So what happens that what you're going to do is that you're going to differentiate the exponent. If you differentiate the exponent, that will give us 6x, and we write the 6x as a base. And what we'll do next is that we'll write back the original question. So 6x e to the 3x squared. That's your answer. Well, that's not really an answer, but I was just showing you what happens when you differentiate e to the x. Alright? And when you differentiate e to the x, you get back e to the x. But I just provide another example to see what they're doing. Alright? So, and you can see why now when you differentiate e to the x, you get back e to the x. Let me try to explain now. So we have e to the x. Alright, so what happens that we differentiate the exponent. When we differentiate x, what do we get? 1. And then we just write back the original thing. You know, 1 times ex and ex just mean the same thing. Alright, so let's get to the question. Alright, so obviously we're going to use the product rule. And what's the product rule? The product rule goes like this. First times the differential of the what? Second. Because of space, let me just try to conserve. So first means you're going to write about the e to the x. First times the differential of the second. Alright. Plus second times the differential of the first. Alright, so as you can see, we can factorize out e to the x. So if we take out e to the x, I'm going to bottom of the screen here, e to the x, what left back is just what? 1 over x plus what? ln x. So our answer there is A. Alright, so this question wants to find out if the function is increasing or decreasing. Now, a function is increasing when dy dx is greater than 0. A company's function is decreasing when dy dx is negative. Alright? So So what we're going to do is that we're going to differentiate this function and input x equals 0 and observe what happens to the function. If when you do that, if it's a positive term that you get, it means that it's increasing, and if you get a negative expression, it means that is decreasing. All right, now mind you, don't get this mixed up. We're not talking about critical points or turning points. All right, and I don't want to mix up that what we just said a while ago. All right, so we're going to differentiate f of x, so it becomes f prime x. That's going to be 6x squared subtract 3. So what we're going to do now is that we're going to replace x with what? 0. All right, so this is a little no-brainer. So 6 times 0 squared subtract 3 will always go away, not true? So end up with negative 3. All right, now this value here is a negative value. It means that it would have been less than 0, meaning that the function is decreasing. So the answer there would have been A for apple. If it was like say positive 3, it would mean that the function is increasing. All right, so moving on smoothly. All right, so here now we have another function to differentiate. But what do you notice about this function here? It's a fraction or a quotient, isn't it? And we have something called the quotient rule. Now this is what I remembered in high school. All right, for the quotient rule, it's the bottom number multiplied by the differential of the second number or second term. Hold on, my apologies. That's the product rule. It's bottom, this is the quotient rule, bottom times DC of the top subtract top times DC of the bottom, or bottom number, all over bottom number square. And the bottom term here is x, so it becomes x squared for the bottom number or the denominator. So bottom is here is it's going to be what? ln. Alright, tell you what, let me remove this because I know the logo for we video would have been on the top right. So according to this thing here, it says write the top number first. Sorry, write the bottom number first, which is what? X multiply by the differential of the top number. So you're going to differentiate ln x, which is what? 1 over x. And we can see the answer for that right away. Subtract the top now. Alright, so the top would have been what? ln x times differential of the what? The bottom, which is 1, all over bottom square, which is what? X squared. So all we need to do is just simplify this expression here. Alright, so going up top, x times 1 over x will give us 1. Subtract ln x times 1 is just ln x all over x squared. Alright, so let's look at this question here. Let me see how many questions I have. Whoa, that was the last question. This is the last question. All right, so it says if g of x is equal to that expression here, then the critical values. All right, so yet again now we're talking about the point on a curve where the gradient is 0, or where the curve is just about to turn. Just imagine you're in a plane, and when you're plane just about to turn, all right, at that point there, that's going to be your stationary point, turning point, or critical point. All right, now if they ask you to find the critical point, it's different from asking what the critical values are. But the critical values are just the x value that you replace x with when you differentiate it a second time. All right. All right. So to answer this question, what we're going to do is to differentiate the g function here, so it becomes g prime of x, and that is equal to 3x squared minus 27. All right. Now the critical values would have been, well, the point at which the curve starts to turn. Not true. And then now g prime x is equal to 0. So what we need to do is to solve this this thing here, aren't we? So what we're going to do is that we're going to put over negative 27, and we get positive 27. By the way, this is just one approach. I could have actually factorized out this thing here as a difference of 2 squares and solve it. So end up with, so what I did is bring over negative 27, or add 27 to the left hand side of the equation and also to the right hand side of the equation. All right, and we end up with 3x squared equals 27. And what we do is we're going to divide everything by 3. The 3 cancel, so x squared is equal to 3 into 27, which is 9. And to find x, so we just find the square root of 9. But when you find the square root, ladies and gentlemen, let me use my eraser here. Yes, when you find the square root, you always get a positive or a negative. So in this case, it's actually positive and negative. Sorry, that's not negative. Positive and negative. Square root of 9 is 3. So these are our critical values. All right, now if they ask us to find the critical points, what we're going to do is that replace the x values, the plus 3 and the minus 3, in the original equation and get the corresponding y values. All right, so when you, for example, suppose I use positive 3, and when I put positive 3 back in original thing, I get 4. So you know what the 3, 4 represents? 3, 4 represents the turning point, critical point, or stationary point. But if them ask you to find the critical values different from point, you know. They're talking about when you put it equal to 0 and you solve for x. So we solve this for x and we got what? Plus 3 and negative 3. Alright? Alright. So that's that. And I believe this is the end of the presentation. I hope you really learned a lot. Alright, so thanks for watching, and I'll see you guys around. Take it easy, keep safe, never stop praying.